Welcome everyone. In this video we will continue our discussion about second order linear homogeneous differential equations. This is the second video on this topic, so if you haven't seen the first one, you can go ahead and check it from the cards right now and also from the descriptions part. Now, with that being said, to make a quick recap, for a second order linear homogeneous differential equation, we have a constant, times y double prime plus b, another constant, times y prime plus c, another constant, times y equaling 0. This is a second order linear homogeneous differential equation. And in the last video, I discussed that something in the form e raised to the power of lambda x would solve this, okay? So let's just say that f of x is a solution to this differential equation, which I will simply denote with f. Now, if this is a solution, so this is given that f is a solution, what does it mean? Well, it means that a f double prime plus b f prime plus c f equals 0, because that is what it means to be a solution of a differential equation. You need to satisfy the given equation, right? Now, with that being said, I wonder, is a constant, so let's say c times f, also a solution, right? If I just multiply the already existing solution with a constant, with a number, is that still a solution to the differential equation? Well, let's see. So we will substitute this into our equation. We will have a. Now the second derivative of c times f, c comes out, it is a number. We get f double prime plus, similarly bc, not y, f prime plus capital C, lowercase c, f. Now, does this equal 0? Well, let's factor out the little c. We have a f prime prime plus b f prime plus c f. Well, we know that this is 0, so this is 0. Which means that c times f is also a solution. Interesting. Now, let me show you something that is even more interesting. What if we know that g of x, which I will denote with g, is also a solution, And you might be asking, hold on a second, it doesn't make sense that we have two different kinds of solution. Well, it actually makes sense, because from the last video you can remember that this equation boils down to this: a lambda squared plus b lambda plus c equaling 0. And this is a quadratic, so it can have two solutions. That's why it makes sense that we consider two solutions, f and g, alright? This is a second order equation, so we can have two solutions. And in fact, we have infinitely many solutions. You will see what I'm talking about. So we have this. Obviously from this, we can see that c times g would be a solution, right? Nothing was special about f. G also satisfies the same condition. What I wonder is, though, does f plus or minus g satisfy the given differential equation? So is this also a solution? Well, let's check it out. We will have a times, we have y double prime, so we will have f plus g, and we will take double prime, right? How does that happen? Well, we can simply get rid of the parentheses and take the derivative of each separately, twice of course, so we get this, plus b f prime plus or minus g prime plus c f plus or minus g. Now, does this equal 0? Well, look at this. If I distribute the parentheses, I will have a f double prime plus b f prime plus c f. This is the first term, and then a plus or minus a g double prime plus bg prime plus cg. Well, this part is 0 because f is a solution. And this part is also equal to 0 because g is a solution. That means the whole expression is equal to 0. Alright, so we got something interesting, a result that is interesting. We found out that if f and g are both solutions to a second order linear differential equation, then their sum or their difference is also a solution. And now I want to briefly consider the most general case. We want to finally ask, is C1 a constant times f plus or minus C2 another constant times g? Is this also a solution? And yes, it will be a solution. Because think about it like this. Think about it like this. If you look at the last example, the only thing that would change is that we would have a C1 here and a C2 here outside of the parentheses. And since this factor is already 0, no matter what this constant is, we will still get 0. So this will also satisfy the given differential equation, given that f and g are solutions to the second order linear homogeneous differential equation. Alright? So what I'm trying to arrive at is that if you find a solution to a second order linear differential equation, then you need to make sure that you consider all the cases so that you can give the most general answer. And also look at this. This also has other cases in itself. We focused on this part, right? It is the case where C2 is equal to 0. Or we focused on this part. It is where C1 is equal to 0. Or even this first statement that we started with. It is the case where C1 is equal to 1 and C2 is equal to 0. What is this comma doing here? Okay, so as you can see, the most general case agrees with the special cases that we have already discussed. Anyways, I hope this video was helpful. If you have any questions, please write them in the comment section. I hope to see you in another video. Until then, take care.